are just revision of what we already know. Okay. So today, the introduction say recall what we are asked to evaluate. When we are asked to evaluate the integral of f of x dx, then we are being asked to obtain a solution whose derivative is equal to the integral. For example, we say that integral of 2x dx is x squared plus c. So because if we differentiate x squared plus c, we are getting 2x. So when we talk about integration, we are talking about antiderivative. That is, you differentiated a function because before you got something. So we want to get back to that original function. So for example, we know that if I have x squared plus c, when I differentiate, I'm going to get 2x. Now I have 2x. I want to go back to the original function, which is x squared plus c. And that's what we call the integration. Equanim, come. In view of this, we have the following basic integration results. So just revising, we know that when we differentiate e to the power x, we'll get e to the power x. So it means that when we integrate e to the power x, we have to get e to the power x. But we have to add a constant c, because we know that anytime we differentiate a function plus a constant, we're going to get the integrand. Okay. So integral of e to the power x ds is e to the power x plus c. And then integral of 1 over x is equal to ln x plus c. Okay, so when we differentiate ln x, we know we're going to get 1 over x. Then integral of sine x is negative cos x plus c. The integral of cos s ds is sine x plus c. So these are some few integration rules. Now, the main issue is that we often encounter integrals involving either the natural exponent, natural log, or trig function that are not the same as any of the basic form we have above. In this case, our goal is to make a change of variable to convert the given integral to one of the basic form above so that we can evaluate it. So what we are saying is, sometimes we encounter, so we are given some basic rules here. But what happens if the function given is not or does not fall under this? So sometimes we have to change some of the variables to look like what we have over there so that we'll be able to apply the rules we have there. So example is if I have integral of e to the power x, e to the power 5x. Okay, so example, we know that anytime I integrate e to the power x dx, I'm supposed to get e to the power x plus c. So here, but here I'm giving integral of e to the power 5x dx. So the power here is not x, it is 5x. So how do I integrate this? That's when I integrate, I will not get e to the power x. So what we have to do is we change the variable here so that it will look like similar to e to the power x. So that's what we do. So we'll let any variable, we can make it a, but I will use u. So let u be equal to 5x. Anytime you change the variable here, then this, the dx2 has to change. So I'm changing my 5x to u. If this is u, then I cannot integrate e to the power u over dx. So my dx here should also change to du. So I will differentiate. I'll have du over dx, and this will give me 5. So I have to make du dx the subject. So my dx will be equal to du over 5. So this means that my function here, this now becomes integral of e to the power u. And I know that now my dx is du over 5. which is the same as 1/5. I know 1/5 is a constant. Integral of e to the power u du. Now, from the basic, this definition, I know that when I have e to the power u, when e to the power x, it will be e to the power x plus c. So this means that this I have 1/5 e to the power u plus c. Then I'll go back and make the substitution for u. I know that my u is 5x. So that's 1/5 e to the power 5x plus c. So anytime I differentiate e to the power 5x, I'm supposed to get 1/5 e to the power 5x. So, please, are you okay? Hello, students.
Hello, madam.
Hello, madam.
Are you
Hello,
okay?
madam.
Is it okay?
Yes, madam. Yes, please.
Yes, please.
So the next one, I want to integrate e to the power 3/x squared plus 2. So here too, you can see that e to the power 3/2, I don't know how to do that. So I will represent it by u. So I want to integrate e to the power 3/x all over x squared dx. So what I will do is I want the exponent to be equal to u. So let u be equal to 3/x. So I have to change my dx to du. So I'll have du is equal to, and what do I get when I differentiate 3/x? Please differentiate it for me. I want to differentiate this with respect to x. Please Dorcas, differentiate this for me. Hey, students, am I online?
Madam,
Yes,
please,
madam.
you get minus 3
Minus 3x
over x squared.
Over x
power
squared.
negative.
Okay. So what will be the u? My dx, make dx the subject. So my dx will be equal to what? What is dx?
Minus x squared on 3.
3x squared over 3.
Minus x squared
Squared
on
over
3.
3. U.
Okay, so that's my dx. So I'll go and do the substitution. So I have the integral e to the power u. My dx is minus x squared on 3. And then already I have x squared here. So this x, okay, so times the u, please, times the u. So we're to make dx the subject. So the u. So the x will take care of the x here, so that I have -1/3 integral of e to the power u du. Then I can integrate directly. This will give me -1/3 e to the power u plus c. And I know that my u is 3 on x, then plus c. Is it okay? Hey, then the school from before mom got me home. I did there.
Madam, we are okay.
Madam, we are here.
Okay, let's continue.
Hello, madam. Please, you cancelled x squared the 2x squared over here, over there.
Yeah.
E to the power u over x squared. I saw you cancelled it with the other x squared.
X squared. Yeah.
Madam, please, can you explain that?
Hey. Can I explain how x squared over x squared can cancel?
Madam, because of the negative in between them.
So I brought the negative outside. So that's why I have negative 1 on 3.
Oh, okay. Madam, I'm okay.
Okay. So another one, we want to integrate. Thank you. We want to integrate x over x minus 6 dx. So this one too, we can use the u substitution. So I will let my u be x minus 6. So that my du be equal to dx. And then here my x will be equal to u plus 6. So when I come back here, so let me just write. I want to integrate x over x minus 6 dx. Okay. I just want to look at something. Please give me a minute. Okay, so let me just use this method. So we can have another method, but let's use this. Equanim, come. So let u be equal to x minus 6. So that my x will be equal to u plus 6. So my dx will be equal to u. So I go back to the function here. This function now becomes my x's. So since I've changed the down one to u, the top one should also be u, and my dx should also be changed. So the top one will now be u plus 6 divided by u, and then my ds is also u. So now the function is integral u plus 6 over u du. And we know that u plus 6 is the same as u over u plus 6 over u, then du. So this is the same as that. Hey, don't forget. Man, don't forget. So u goes with u, and I will have integral 1 plus. So integral of 1 du plus integral of 6 over u du. And we know that anytime we integrate 1 times the u, we're going to get u plus, and this is the same as 6. So I can bring the 6 here, then I'll be left with integral of 1 over u du. And from the theory, we know that integral of 1 over u is ln u, then all plus. So so that's what you're going to get. Any question?
Madam, please, can you scroll so that I want to look at something?
Can I what?
Scroll upwards.
So that's all we have. Is it okay?
Yes, please. I got confused where we got the X classes.
When we got the S plus.
Yeah, X classes.
And so let U be, I'm saying that let U be equal to X minus 6. So if I make S the subject, my X will be U plus 6. Is that not it? So in place of my X here, I'm writing U plus 6.
Madam, I've gotten it. Thank you.
Okay, thank you. But if you don't want to use the U substitution, but now our focus is on the U substitution. But the thing is, anytime you have the degree of the numerator and the denominator the same, then you can also divide to solve it. So we're going to get X minus 3X. And when we divide, what do we get? This one will have 1. This will go into this one, 1. Then this times this will give me X. This time this give me minus 6. So negative. Okay. This minus this will give me this. This minus this will give me plus 6. So it means that the function now becomes 1 plus X minus 6 over A. What is it? You're trying to say, is this X over
It's
6?
6 over X minus 6. 1 plus
This is
6 over
1 plus 6 over
6 over X minus 6.
minus 6. Okay. Then you can just integrate. So when you integrate this dx, this will give you integral of 1 dx plus 6 times integral of 1 over x minus 6 dx. And we know that this will give me x plus, and this one will give me, this one will give me 6 ln x minus 6, all plus c. So that is it. So when we come here, this u is x minus 6, then plus ln, my u is x minus 6, then plus c. We know that our c is a constant, and then I can rewrite this as x plus, I have 6 here, 6 ln x minus 6 plus, so 6 plus 6, negative 6 plus c is still a constant, so you can write it as plus c. It's the same constant, so you can write it as c or k. It's the same thing. But the focus, what we are doing here is U substitution. So that's what we want to focus on. But I'm just teaching you another method that when it's like that, you can use this. But the focus is on the U substitution. So that's what you're going to get, which is equal to x plus 6 ln x minus 6 plus, so the constant minus a constant will still be constant. So that's what we have. Then you have another one here. We want to integrate x plus square root of x plus 9 over 2x dx. So we let the numerator be equal to u. So you have u is equal to square root of s plus 9. Then you can square both sides to get rid of the square root. So you have u squared is equal to s plus 9. Then you have your x. Your x is equal to u squared minus 9. Because we have x here. So that when I start with the substitution, I'll get a value for my x. Okay. Now, when I differentiate, I'm going to get the x to be equal to 2u dx, du. So I go back and then substitute. I know my u is square root of this is now u. Then divided by 2, my x is now u squared minus 9. And then my dx is 2u du. So I will start integrate with my integration. So I have integral of, so 2 will go with 2. So I have u squared du over u to the power 2 minus 9. So how do I integrate this one too? Both of them have the same degree. Okay. So here, this is what we did. The top one, we added 0. We added 0 by subtracting 9 and then adding 9. So that we have u squared minus 9 plus 9. Minus 9 plus 9 is still 9. It's still 0. Divided by u squared minus 9. And then I can rewrite it as u squared minus 9 over u squared minus 9. Then plus, then I'm left with the positive one, which is 9 over u squared minus 9. So I separate them du. But I just told you that, okay, so this u squared minus 9 can go with the u squared minus 9. So this will give me 1 du. But anytime you have something like this, you have to decompose it to partial fraction. Okay, so we learn decomposition into partial fraction. And we know that u squared minus 9 is the same as u is the difference of 2 squared. So this will be 9 over u minus 3, u plus 3.
Madam.
And this is, hello?
Madam.
Hello, yes, madam.
Please, please, can you go to the board and solve it for us? The slice in a shortcut.
Yes, shortcut. Okay, so I want to integrate square root of x squared minus 9 over 2x dx. Now I'm saying let u be equal to square root of x squared minus 9. But remember, I have some square here. I have some, oh, sorry. Is it x squared? Is it x squared or just x? It was x plus 9.
X plus 9.
So this x plus 9, x plus 9. So there is some x at the denominator. So since I've changed the numerator to u, I have to change the denominator to expression in terms of u. So to make u the subject, I can square both sides. And this will be u squared is equal to s plus 9. Then my x will be equal to u squared minus 9. Then also have to change this the x2 to the u. So I have the x to be equal to 2u du. So I go back and make substitution. So the function now becomes integral. I know the numerator is now u divided by my denominator. I have 2 and my 2x, and now my x is u squared minus 9. And then my dx is 2u du. So this u can take care of this u. And this now becomes integral of this u multiplies this u. So I have u squared over u squared minus 9. Then I have the u. So I want to play around this one. So I want to rewrite this one. This is the same as u squared plus 0 is the same as u squared. And my 0, I want to write it as, u squared, integral of u squared minus 9 plus 9 over u squared minus 9. So this is 0, 9 plus 9, minus 9 plus 9 is still u squared, then du. And then I know that I can separate this one by writing u, integral of u squared minus 9 over u squared minus 9 du plus integral of, so when this one goes with this, then I'll have 9 going with this. So 9 divided by u squared minus 9 du. But this, I know that this can cancel this, so I have, so this is equal to integral of 1 du plus integral of 9 over u plus 3 u minus 3 then du. But when I have this like this, it will have to decompose it to partial fraction. So this is equal to integral of this is u plus, and when I decompose this, I have to start it from somewhere. So I have 9 over u plus 3 u minus 3, which is the same as a over u plus 3 plus b over u. U minus 3.
Hello, madam. Please, we can't hear you. Hello, madam.
Doc,
Hello, madam. Hello, madam.
Yes, Oliver.
Yeah, dokie. Nkuni mame.
the future study what?
Hello, nkuni mame.
We are some. Couldn't my message say?
Hello, madam Justina.
Hello. Yes.
Please try and contact madam for us and let's see.
Okay.
Because I think she's off.
Okay.
Doc, you continue for us.
She will join us very soon.
Hello, Doki. Dorcas. Doki,
Oliver.
please help me
Oliver.
with the question, right? I've sent some question
Ajay.
at the comment section. Help me.
Okay.
Oh, I'm not ready. Helpful. The integral of x over x minus 6 dx. Why is it that the du is equal to dx?
Differentiation of x will be 1.
Okay. Like before that, you see, we let the u is equal to x minus 6. I don't know if we got it from that end. So let u is equal to x minus 6. So it will be x is equal to u plus 6.
You see, I see one denominator no. Once I want see your s minus 6 wɔ hɔ. Nti
Yeah.
saa x no sɛ wode s minus 6 kɔhyɛ hɔ no ma. Ɛno yɛ
Okay.
s plus 6. Nti wode s minus 6 kɔ replace x na 6 no nyinaa bɛkɔ.
Okay.
Wate ase. Nti ɛbɛka u wɔ hɔ.
Okay. There's a metric. Integral of x over x minus 6 dx. Until over down. Now, but let u is equal to x minus 6, right?
Right.
Yeah.
Nti top hɔ na ɛyɛ x no bɛba abɛyɛ u.
Ɛhɔ nom ba bɛyɛ u no.
Sɛ ɛhɔ no yɛ once top hɔ yɛ s minus 6. And yes, you replace x with u. And yes, sir.
Top na main question ankasa no yɛ x over x minus 6 anaa?
Nti baby x will be no. You replace no.
Sɛ yɛyɛ ama u abɛyɛ x minus 6.
Good.
So u is equal to x minus 6. So it will be x equal to u plus 6. Sɛnea the numerator no ba bɛyɛ u plus 6.
But once s u plus 6 back, s plus 6 back wɔ hɔ deda. Nti saa 6 no nso bɛba abɛka ho na take 6 no nti ɛbɛba abɛyɛ 6 ni bɛba abɛyɛ minus 6 plus 6 nti ɛhɔ bɛyɛ 0.
Okay. Okay, thank you.
You're welcome.
Hello.
Hello, madam.
Hi, madam.
Please, I'm back. Forgive me, my network was misbehaving.
Hi. You are welcome, madam.
Okay, so the question, we are still on this question. We want to integrate square root of x plus 9 over 2x. And we want to replace the numerator by u. So we are saying that u is equal to square root of x plus 9. So since we have changed the top one to u, it means that everything here should be in terms of u. So I have to change my x here to u. And to do that, we can square both sides to get u squared is equal to x plus 9. Then I make U the subject, so my U is U squared minus U. Then I have to change my dx to du. So I differentiate the function with respect to x. So with respect to u, so I'm going to get x is equal to 2u du. So in place of the x here, I will write 2u du. In place of this x here, I will write u squared plus 9, and then in place of square root of u, square root of s plus 9, I'll write u. So that's what I have here. So I have u over 2 u squared minus 9, which is my x, and then my du is 2u du. So these two can cancel this 2, and then the u can multiply to u. So I have u squared over u squared minus 9 du. So we know that this is a rational function. And to solve this, anytime the degree of the numerator is the same or greater than the degree of the denominator, we can divide. Okay, so you can use long division. And when you use long division, you are going to get 1 plus 9 over, okay, so that would be 9 plus 1 over u squared minus 9. Or I decided to add 0 to the numerator. So I have u squared minus 9 plus 9 over u squared minus 9. And I can rewrite this as u squared minus 9 over u squared minus 9 plus 9 over u squared minus 9. But if you think this one will be difficult for you, you can just write so if you think this one is difficult for you, you know that here you have u squared over u squared minus 9. We use long division, which will be u squared here, and then u squared minus 9. And then u squared will go into this one, 1. Then you multiply u squared by 1, which will be u squared. You multiply negative 9 by 1, which will be negative 9. Then you subtract, you have negative here. This minus u squared minus u squared will give you 0. And then there's 0 here. So 0 minus minus now will give you plus 9. So when you write this one, this is the same as 1 plus 9 over u squared minus 9. So the expression here is the same as integral of 1 plus 9 over u squared minus 9 du is the same thing. So that when you integrate, you're going to get integral of 1 du plus integral of 9 over u squared minus 9 du. And you know that this one, you have to decompose it to partial fractions. So this will be integral of 1 du plus, and this one will give you integral of a over, so this is the same as 9 over u squared minus, no, not u squared. So that's the same as 9 over u plus 3, and then u minus 3. So u plus 3, u minus 3, we know this is a 9 over u plus 3, u minus 3 is the same as a over u plus 3 plus b over u minus 3. Then to solve this, to solve for a and b, this is the same as 9 into a u minus 3 plus b u plus 3. So when u is equal to 3, positive 3, this one will go. So I have 9 is equal to 6b. So my b will be 3 over 2. And then when s is equal to negative 3, this one will go. So I have 9 is equal to minus 6a. And then my a will be negative 3 on 2. Okay, so I go back here. Is it true? Is it true that I'll get negative 3 on 2? And then positive 3 on 2?
Yes, madam. Yes, please.
So I go back here and I have integral of 1 du plus integral of 3 over 2 times, so that's negative. So that's negative. The A is negative. So I have negative 3 on 2 into S plus 3 du is U plus 3 plus integral of 3 on 2 into U minus 3 du. Then I know that when I integrate this, I'm going to get U. Then when I integrate this, I'm going to get 3 on 2. And the integral of 1 over U plus X is ln U plus 3. Plus integral of this is 3 on 2 ln U minus 3. All plus C. And we know what our U is. So you just substitute your U, which is equal to square root of X plus 9. So that is what we will do. Is that okay?
Yes, please.
Okay, so I have my U plus 3 on 2, integral of that, which is 3 on 2 ln square root of X plus 9 minus 3 over 3 on, so the minus 3 on 2 ln of, so I have U plus 3 plus C. So that's what we were supposed to get.
I have a small question.
Okay.
See where you
Please,
made YouTube. Hello?
Yeah, please,
Madam,
I'm here. Yeah, I'm
where
here.
U is equals to the square root of X plus 9. I don't know why didn't you differentiate the square root? And then you have to square both sides for the square root to go.
Okay. So we said we want to substitute. So this is the by substitution method. So in place of this, I want to replace the top one by U. So it means that the denominator I have to change it. Okay. So I change this one to U. If I do direct differential, I will not be able to take care of the X. But I want to take care of the X. So if you just do direct substitution, you let your U be equal to square root of X plus 9. Then when you differentiate, so let's see. So let's see what you were talking about. So because I have to change my du, I have to change my dx, I have to change, something should happen to the down one, to everything should change. So I cannot continue with the u. Since this one has changed to u, this one too should change. If I can do something that can cancel out, it's fine. But if I cannot cancel out, then I have to change it. So let's assume we have u is equal to square root of s plus 9, which is the same as s plus 9 to the power half. Then when I differentiate, the u will be 1 over 2 s plus 9, then times 1. Then I go and substitute, okay, so the x. So my dx will be equal to, my x will be equal to du times 2 over this minus half, right? So which is the same as, okay. So this is the same as, so my du is 1, or is the same as dx over 2 roots x plus 9. Just look at what we have here. Then, so that's du. Then I have the, okay, the x, this, the x is already there. So I'm making the s the subject, so I didn't. So my dx is equal to du times 2 times root of s plus 9. I still have u. So when I go back and do the substitution, here is u, here is 2 du root of s plus 9. And I still have 2u inside. So I'll not be able to work that. Okay. So the focus is I want to change everything to u. So since this is u, I have to change this one to the x2 to u. That's the reason why I squared both sides. So when I square both sides, I'll be able to get an expression for x, which is u squared plus 9. Then I can get expression for the u, which is 2u du. Are you okay?
Yes, madam. I was thinking that maybe because it's the numerator, that's why you have to do that. Okay, thank you.
So sometimes, everything you have to look at how. So sometimes you will not even know what to do, but you see that when you start something, you will be locked out somewhere. So you have to choose another approach. But the more you work, the more you get the technique and then how to solve it. So there's another one. We want to integrate sine to the power 5x dx. And we know that sine to the power x dx is the same as sine to the power 5x times sine s dx. And sine to the power 4 is the same as sine squared x all squared sine x. So we also know that sine squared is the same as 1 minus cos squared x. So in place of sine squared x, I'll write 1 minus cos squared x all squared sine x. Then I will let my u be equal to cos s. If u is equal to cos s, then I know that my du will be equal to negative sine s dx. So I make the s the subject, so my dx will be equal to du over sine x. Then I go and make substitution. So when I make the substitution, okay, so I'm back as a metro board this into the metro. You can kind of okay, so I want to integrate sine to the power 5x dx. And you are saying this is the same as sine to the power 4x sine x dx. And we know this is the same as integral sine squared x squared sine x dx. And we know this is the same as 1 minus cos squared x sine x dx. So I now start with my u substitution. So I will let u be equal to cos x. Then it means that my du will be equal to minus sine x dx. So this means that my dx will be equal to du, negative du over sine x. So I go back and I substitute everything here. So this is the same as integral of 1 minus, remember I'm saying that u is equal to cos s, so this is u squared. Then I have my sine x. I will not change this because I can see that something can cancel out, so I will leave that one. Then my du is now negative du over sine x. So because I know something can cancel the sine x, that's why I didn't touch the sine x. So this can go with this. Then I'll have negative integral of 1 minus u squared, then du. This negative has come here, which is the same as u squared minus 1. Then I can start integrating. So that's what we have here. So I have negative into 1 minus u squared all squared du. Okay. Then when I expand this, this will give me negative. When I expand 1 minus u squared all squared, I'm going to get 1 minus 2u squared plus u to the power 4 du. Then I can start integrating. When I integrate negative 1, I'm going to negative 1 du, I'm going to get negative u. Then I have this minus will be plus. So I have 2. Then u to the power 2, when I integrate, I'm going to get u to the power 3 over 3. So that's I have 2 over 3 u to the power 3. Then this one, because of the negative, this will be negative. So I have negative u to the power 4. When I integrate negative u to the power 4, I'm going to get u to the power 5 over 5. So this is negative 1 over 5 u to the power 5 plus c. Then I know that my u is cos s. So in place of u, I will just write cos s. So this will be cos s plus negative cos s plus 2 on 3 cos to the power 3x minus 1 over 5 cos to the power 5 x plus c. Okay, so that's what I was talking about. So any question? We've solved some examples under integration by substitution. Do you have any question?
No, please.
Okay, so if you have no questions, then it means that you have to look for more examples, because every example and then how you can solve, you have to how to use the U substitution. Okay, so you have to get more examples, and then it will help you to get the understanding. Okay, so we are done with the substitution, integration by substitution. Even integration by substitution, you can see that we even solved integration by parts somewhere. Here we use integration by parts. Sorry, not integration by parts, integration by a partial fraction. You saw that we needed to decompose it to partial fraction. So that's what we did here. So here we combined by substitution and then by partial fraction. And you know that you can only apply the partial fraction, decompose to partial fraction, if the degree of the numerator is less than the degree of the denominator. And if they are the same, you have to divide. If the numerator is greater than the denominator too, you have to divide. And then also for decomposition, to decompose a function into partial fraction, we learned it from MAT203D, that you have to look at first the factors, whether they are repeated roots, whether they are distinct roots, whether they have complex roots and others. Okay, so to use the partial fraction, you have to revise all that before you can apply the partial fraction. Okay, so integration by parts, this is the method, the formula that we use. It says that try and memorize the formula. So they are saying that the function will give, the equation or the function will be given as integral of u dv. So you have something like u and then dv. So the formula is you have to get your uv minus integral of v du. And they are saying that note that the integral of u dv is the original question of the structure. So the original function that you'll be given is the u dv. And dv is the most complicated or weird function, but that can still be integrated. So when you look at it, your dv will be the most complicated or the weird function. And your derivative of u should be simpler than u. So when you differentiate your u, it should be simpler than your u. So please keep this in mind. Now, to apply the integration by parts, we have different types of problems. So we are saying that the first one, we are saying that if you see a problem that looks like this, you have x to the power n, then e to the power ax, and then we have x to the power n sine a x dx, or x to the power n cos a x dx. When you see it like this, you let your u be x to the power n. Please, anytime you have a question like this, you let your u be x to the power n. Then 2, if you have integral of x to the power n ln x dx, be x to the power n arc sine. When you talk about arc sine, it's the same as sine inverse. So x to the power n sine inverse of ax ds, x to the power n tan inverse of ax ds. That one, you let your dv be x to the power n. So please see the difference. If it's sine x to the power n sine x, you let your u be x to the power n. But if it is x to the power n sine inverse, then you let your dv be x to the power n dx. And then in the following, if you have integral of e to the power ax sine bx dx, or e to the power ax cos bx dx, then you let your dv be e to the power ax. So please pay attention to these three. So with the 3 in mind, we want to integrate x e to the power 2x dx using integration by parts. So under which of the 3 points does this equation fall? Let's look at this. Under which of them does it fall? Is it the type 1, type 2, type 3?
Type 3.
This is the question, x e to the power 2x dx. And let's see, we have type 1, type 2, type 3. So under which one does it fall? Is it type 1, type 2, type 3? Oliver.
Hello, madam.
And so which of them does the question fall?
Madam, please let me see the question again.
Integral x to the power e to the power 2x.
Type 3.
Okay, Oliver is saying type 3. Kwekubuama, what do you think?
I think it's type 1A.
Okay, so Buama is saying type 1. Type 1A. Okay. Any other? Buama, still, are you saying type 1A? Kwekubuama?
Hello?
Is it
Hello?
still type 1A? Is it still type 1A?
Let me look at the type 3. I just came in,
Oliver,
so
Oliver, is it still type 3?
Yes, madam. Madam, with the revoting power.
Look at it again. This is the question. And let's go back. Which of them? Is it type 1 or 2? Dorcas, is it type 1 or type 2 or type 3?
I'm type 3. Oh.
Gifting.
Type 1A.
It's type 1A. So let's go back. We can see that this is x to the power n, and our n is 1. E to the power 2x. So it's the type 1A. X to the power n, e to the power as. And they are saying that if we say it's like this, then we should let our u be x to the power n. So we come here, our x will be, our u will be x, and then our dv will be e to the power 2x. So let's go to the board. So I want to integrate x e to the power 2t, 2x dx. Now we can see that this one falls under type 1a. And the 1a says that if we see integral s to the power n e to the power a x dx, then we should let u be equal to s to the power n. So here I will let u to be x. And then so this means that my du will be equal to dx. And then my dv will be e to the power 2t, 2x. Why am I writing t? Because in the formula, they are saying that it will be integral of u dv, which is equal to uv minus integral of v du. So it means that I need u, I need v, I need du. So in the original formula, I have u and dv. So I have to get my du. So my du will be equal to dx. And I have to get my v. So to get my v, it means that I have to integrate. So what do I get when I integrate e to the power 2x dx? Please, what do I get when I integrate e to the power 2x dx?
E to the power x on 2.
Eh?
E to the power 2x on 2.
E to the power 2x on 2. Okay. So this one, I will not bring the constant of integration because of what I'm doing here. So this is my v. So I go back and then make my substitution. So my u is x. My v is e to the power 2x over 2 minus integral. I know my v is e to the power 2x over 2. My du is dx. So this is the same as x e to the power 2x over 2 minus, I can bring 1 over 2 here, integral e to x dx. So we can go ahead and we can continue. This is x e to the power 2x over 2 minus 1 over 2. Please, what do we get when you integrate e to the power 2x dx? Dorcas. Dorcas, am I online? Dorcas. Eric, what do I get when what do I get when I integrate e to the power 2x dx?
1 over 2.
1 over 2.
E to the power 2x.
2x. Now I can bring my constant of integration. So this is the same as x e to the power 2x over 2 minus 1 over 4 e to the power 2x plus c. So that is it. So I'm going to get x over 2 e to the power 2x minus 1 over 4 e to x plus c. So let's look at this one too. X e to the power negative x ds. What kind of case does it fall under? So the type, is it type 1, type 2, type 3? And then we slow me you don't want to participate. You have to finish this and start with the other one. Hello.
Hello, madam.
If you
Type
mind,
1A.
so that's also type 1A. So let your u be
Yes.
x, so your du will be dx. Then your dv will be e to the power minus x. So this means that my v will be minus e to the power minus x. Okay. So quoting the formula is uv minus integral of v du. So I come back, I have my u to be x, my v to be minus e to the power x minus integral of v is minus e to the power x, and then my du is dx. So I will maintain this minus x e to the power minus x. I have minus minus, which will be plus the integral of e to the power minus x dx. Then I will integrate e to the power minus x dx. E to the power minus x dx will give me minus e to the power minus x plus c. So that's what I get. I have another one here. This is integral ln x dx. So this one will be which type? Ln x dx. Type 1, type 2, type 3. That's type 2a. So the type 2a says that our v to be x to the power n dx. So let's come here. So here, our u will be ln x, so that our du will be 1 over x dx. Our v is du, because s to the x, it is x to the power 0 du, which is the same as du. Okay, so my dx, sorry, so my dv is equal to dx. So which means that my v will be equal to x. So I go back to the formula, which is my u dv is equal to uv. My u is ln x, and then my v is x minus it. Okay, so let me just write. So I want to integrate ln x dx. So this, I will let my u be equal to ln x, so that the u will be equal to 1 over x dx. Okay. Then my dv will be equal to dx, so that when I integrate both sides, I'm going to get my v to be equal to x. I go back to the formula. The formula is integral of u dv is equal to uv minus integral of v du. So my u is ln x, my v is x, minus integral of my u is x, my du is 1 over x dx. That's my du. This is my du. So this goes with this, and I have, this is the same as x ln x minus integral of dx. And this is x ln x minus, this is x, then plus c. Is it okay? Is it okay?
No, madam, please, can you go over again?
Okay, so I think what you have to get first of all is the formula. The formula is u dv is equal to u times v minus integral of v du. So this means that the question will be given in the form of u dv. And Dorcas just told us that our question falls under the type 2a. And when it's like that, it says that our du, our dv to be, so that one is x to the power n ln x dx. If it's like this, then according to the rules, my dv should be x to the power n dx. But here it looks like x to the power 0. Our v will be x to the power 0 dx. So that's what we have here. S to the power 0, we know it's 1. So we have dx. And then our u will be ln x. Okay, so we are trying to get what we need in the formula. We need u. Now we have u. We need v. But in the question, we have the v. So how do you get v? We have to integrate the dv. We have dv is equal to dx. So when you integrate the dv, we are going to get a v. So when you integrate, you're going to get v to be equal to x. Okay. And in the formula too, we need v and u. But in the question, we have u. So you have to get the u. So the u is, you have to differentiate this. The u will be 1 over x du. So after getting everything, I'll just go and do my substitution. So my u is ln x, my v is x, so I'll substitute it there. Then minus integral of v, my v is x, so my v is x. Then my du is 1 over x dx, so I have 1 over x dx. So I have x times 1 over x, so x can go with x. So this side will be only integral of dx. Then I have ln x times x, so I can bring the x out here so that I have x ln x minus integral of dx. And I know that when I integrate dx, I'm supposed to get x plus c. So this is x plus c. So the whole function is x ln x minus x plus c. Is it okay?
Yes, please.
Yes, madam.
Okay.
Okay.
So you have another one here.
Amen.
We want to integrate x 5 to the power x dx. So thus I will let my u be x. Okay, so the most important thing is whenever you are given the formula, you just try to write, when you're given the question, you try to write the formula down. So the formula is, integration by part formula is integral of u dv is equal to uv minus integral of v du. Now the question given is integral of, what is it? Integral of x 5 to the power x dv is equal to, okay, so that's what we want to do. So I will let your u be equal to x. So this means that my dv will be equal to 5x dx. Sorry, this is dx. So I will need my v. I will need my dx because I have u, so I will need v. I have, when I get the v, I have to get the u. So first, let's find the u. So my du will be equal to dx. And the next one, I have to get my v. So my v, when I integrate this, I'm going to get 5 to the power x ln 5. So this is 5 to the power x over ln 5. So that's what I'm going to do. That's what I'm going to get. So I go back and then substitute. So integral of x 5 to the power x dx will be equal to, my u is x, my v is 5 to the power x over ln 5. Then minus integral of v is 5 to the power x over ln 5. And then my du is dx. So this is the same as s 5 to the power x over ln 5. Then this is the same as 1 over ln 5. Integral of 5 to the power x dx. Now this is x 5 to the power x over ln 5 minus 1 over ln 5. And the integral of 5 to the power x dx is 5 to the power x over ln 5. Then plus my c. So the final answer is x 5 to the power x over ln 5 minus 5 to the power x over ln 5 squared plus c. Is it okay? Is that okay?
Yes, madam.
Okay, so let's continue. Okay, so you're going to get x 5 to the power x over ln 5 minus 5 to the power x over ln 5 squared plus c. We have another one here. Integrate. What kind of question is this? Oh, this one is you have to integrate 5 to the power x dx. Oh, no. They are just showing how we got x to the power 5 dx to be 5 to the power x over ln x. So that's what we are showing here. So I think it was this, how we got that. So let me just show you how to get this. So what we are saying is, if I want to integrate 5 to the power x dx like this, then they are saying that this function is the same as e ln. So this is the same as e ln 5x dx. Because you know that e ln, they are inverses, so this can cancel this. Then I'll be left with 5 e to the power x. Now from what we just, okay, so this is the same as that. And then from the loss of indices, 5 ln 5 to the power x is the same as I have x here. Then I have ln 5 dx. Okay. And from what we just learned, we saw that anytime we have exponential function, it will be the original function divided by the power. Okay. The differential of the power. So this will give me e to the power x ln x over the differential of this, which is equal to ln 5. So that's how can we got the e to the power 5 to be e to the power 5 over ln 5 plus c. Ekwe there. Ekwe there. Namun kasami home.
Madam,
kakra.
Okay, so let me just repeat it. E to the power 5x over this. I can rewrite this as integral of e ln. I know we know that e ln they are inverses, so they will cancel each other. So I want to rewrite this as this dx. And this is the same as from the loss of indices. Ln 5 to the power x, I can bring the x down. So this is the same as integral e to the power x ln 5. Then I have my dx. And from integral of e to the power x, okay, so I will let u be equal to x ln 5. So that when I find the u, I'm using u substitution. So the u will be, I have to differentiate only this, which will be 1. Then this is a constant. So I have ln f dx. Is that not it? So my dx will be equal to du over ln 5. So I'll go back here. This will be integral of e to the power u. This is u. And my dx is du over ln 5. Then when I integrate this, okay, so this is the same as 1 over ln 5 integral of eu du. And this is 1 over ln 5. And when I integrate eu, I'm going to get eu plus c. Remember my u is, so this is 1 over ln 5, e to the power, my u is x ln 5, then plus c. Is it 5? Yeah, either 5 or 5x. So I can write e to the power x, then 5, or I can write it as e to the power e ln 5x, like that. Where this cancels this, then I have 5x, only 5x over ln x, like that. So that's how come the integral of that gives me that. Integral of e to the power x dx gives me 5x over ln x over ln 5. Maybe integration by parts. We don't miss some question and problems. But you can get more examples. So sometimes you can get the type A, sometimes you can get the type B, the type 1, type 2, type 3. But you should be able to choose your A and B, and U, and then the V. Please, I'm done. Oh, any question?
Madam.
Oliver, any question? Dr.
No, madam.
You need gifts to do a Hannah. Okay, so we want to move on to integration by parts. By partial fraction, sorry. So as I mentioned, I said that to decompose to partial fraction, you should know the type, especially the denominator. So first, to decompose to partial fraction, first you should check that the degree of the numerator is less than the degree of the denominator. If they are the same, you have to use long division to divide so that you will get the function where the degree of the numerator is less than the degree of the denominator. So that's the first one you have to pay attention to. Then the second, you have to look at the denominator if you can get factors. Okay. So if, for example, if I can have factors like this, then when I decompose, and then you can see that the degree of the numerator is 1, degree of the denominator is 2. So when it's like this, I can go ahead and decompose. But I have this factor and this factor. So I have 2 distinct factors. So the expression will be a over s plus 1 plus b over 2s plus minus 1. So that's the first case. The second case is when you have repeated roots. The repeated roots, you see that is the factors are x minus 1, x minus 1. So when it's like this, when you decompose, it's going to be, and the degree of the numerator is 0, denominator is 2. So you can go ahead and decompose. So when you decompose this, because you have repeated roots, it's going to be a over x minus 1 plus b over x minus 1 squared. If it is to the power 3, then I'll have plus c over s minus 1, 3, here to the power 3. And the third one, this one you can also see that the degree of the numerator is 1, degree of the denominator is 3. Okay, you can see that you have this factor. This is x minus 1, so the factor is s equal to 1. Then you have x squared plus 1. This one will have imaginary roots, x squared plus 4. This one will have imaginary roots. So the first one is real root, so we're going to get a over x minus 1. This one is imaginary roots, so that will be bs plus c over s squared plus 4. So that is it. Then the fourth one is 8x over s squared plus 1. Here, the degree of the numerator is 1. The degree of the denominator is 6. So you can go ahead and decompose. But if I want to find the factors, you see that this will have imaginary roots. My x will be plus or minus I. That will be imaginary. Okay. So it means that when I want to decompose, it will be as. But even though it is imaginary, it is repeated 3 times. So first one will be as plus b over s squared plus 1. The second one will be as plus b over s squared plus 1 squared. It is 3. So I have to get the third one, which is as plus f over s to the power 2 plus 1, all to the power 3. So we have to pay attention to these 4 cases. There are some places that you will combine more than one. You can combine this and this, just like the second one. You can combine this, so the first, second, and then the third or the fourth. You can have combinations. Okay, so you should be able to know how to decompose. Okay, we want to integrate s to the power. We want to integrate s plus 5 over s squared plus x minus 2. We can see that the degree of the numerator is 1, the denominator is 2, so I can decompose straight. Let's see if we can have factors. This is the quadratic equation, and we can have factors, distinct factors. So the factors are s plus 1, s plus 2, s minus 1. So it falls under the first form. So I can rewrite this as s plus 5 divided by s plus 1, s minus 1. Okay. So if I'm able to write it, it means that I'm decomposed. I'm going to get a over s plus 1 plus b over s minus 1. And I have to find the values of my a and b. And we know how to do that. So that's what we are doing here. We want to find a and b. You can expand any method of undetermined coefficients or whatever. So you solve for your a, and you get your a to be -1, b to be 2. Okay. So alternative approach, they are all showing how to get your a and b. So you go back, you're going to get integral of x plus 5 over x plus 2 times x minus 1 dx, which is the same as integral of, okay, so my a is -1 over x plus 2 plus integral of x over x minus 1. Please, there should be dx here. So dx. Now I know that this is the same as -1 integral of x plus 2. In -1 integral of 1 over x plus 2, and integral of 1 plus 2. Integral of 1 over 1 plus 2 is ln x plus 2, so the -1 is here. Then I have 2 integral of 1 over x minus 1, which is the same. So please, the 2 should come here. The 2 did not come. There should be 2 here. So 2 integral of x minus 1 plus 6. Please, there should be 2 here. The b is 2, so there should be 2 here. So final answer should have 2 plus c. I'm continuing on. Wait, so
Okay, madam.
can I
Okay,
continue?
madam. Yes, please.
So this one,
Madam.
we want to integrate s minus 9 over s squared plus 3s minus 10. So you have to, as I said, you have to check the degree of the numerator and the denominator. Numerator is 1, denominator is 2. So I can go ahead and decompose. Let's see if we can find factors for the denominator. Okay. So denominator is s squared plus 3x minus 10. This is a quadratic function. So you can use any of the methods whether factorization, completing of squares, quadratic formula. And then when you use any of that, the formula, the factors will be x plus 5, x minus 2. They are distinct factors. So when you decompose, you're going to get a over x plus 5 plus b over x minus 2. So the next thing is to find my a and b. So this will be x minus 9 equal to a into x minus 2 plus b into s plus 5. So you can choose when s equal to 2. When s equal to 2, my a will go, so that I'll have 2 minus 9, which is minus 7, and then 2 plus 5, which is plus 7. So my b will be minus 1. Then when s equal to minus 5, when s equal to minus 5, the b will go away. Then I have minus 7 here. And here will be minus 14, right? Minus 14. So my a will be 2. So I have the value of a to be 2, b to be minus 1. So the function will be integral 2 over s plus 5 plus integral of minus 1 over x minus 2. Then when I integrate, the ds should come, please. They should have dx. I'm not able to edit it. Enable editing. Okay. So this should have the x. This should also have dx. So please dx. And even this one should also have dx. Okay. So when I integrate, this will be 2 ln s plus 5 minus negative, so that it is negative 1, so negative ln s plus 2, then all plus c. Okay, so that's the final answer we have here. Any question? Any question?
No,
Okay.
madam.
Okay, so still on the partial fraction. So this one, 2. The degree of the numerator is 2. Denominator is 1, 2, 3, 3. So we can go ahead and decompose. And then the factors I have, this is x minus 0. So this is x. And then I have 2x minus 1 and then s plus 2. So I have 3 factors. So when I decompose, I'm going to get a over s plus b over 2x minus 1 plus c over x plus 3. So I have to find my a, b, and c. You know how to find a and b and c. So you just multiply through by the LCM. Then you're going to get something like this. When s equal to 0, my b and c will go away. Then I can find my a. Okay. So when s equal to 0, I can find my a. And my a will be, okay, so let me just look at this. I have 0, 0 here. So negative 1 is equal to a times negative 2. So my a will be positive half. Can you see that? Can you see?
Yeah.
Yes, ma'am.
When s equal to 0, my a will be positive half. And when s equal to half, then a will go away, my c will also go away, then I can find my b. So my b will be 1 on 5. Then when s equal to negative 2, when s equal to negative 2, a will go away, b will go away, then I can find my c. So my c will be negative 1 over 10. Okay, so I can go ahead and then solve for, so I have my a to be 1 over half integral of 1 over x dx plus 1 over 5 integral of 1 over 2s minus 1 dx minus 1 over 10 integral of 1 over x plus 2 dx. Then I know that when I integrate 1 over x, I have ln x plus, then when I integrate this function, I'm going to get ln 2x minus 1 times the differential of this, which is 2. So I have 2 here. So please, you can use integration by substitution to get the answer for this. But this will give you ln 2x minus 1 over 2. Then minus this will be 1 over 10 ln s plus 2 all plus c. So the final answer is 1 over 2 ln x plus 1 over 10 ln 2x minus 1 minus 1 over 10 ln s plus 2 all plus c. So that's the final answer. Okay.
Okay, madam.
So we have another one here. We want to integrate s to the power 2 over x plus 1 to the power 3. So degree of numerator to degree of denominator 3. So we can go ahead and then integrate. This has repeated roots. So, and I can find the roots. The root is s equal to -1. It's not imaginary. It's a real root, but just that it is repeated. So I'm going to get a over s plus 1 plus b over s plus 1 squared plus c over s plus 1 to the power 3. And I have to find my ABC. So any way you find your ABC, please, you do. You can just find the LCM, you multiply it through, you expand. This is, okay, then you find your ABC. So when you find your ABC, your A will be 1, your C is 1, your B is -2. So I think your A will also be 1. So you go back and make substitution. You have 1 over s plus 1 ds plus integral of -2 over, your B is -2, so -2 over s plus 1 square ds plus 1 over, so your C is also 1 over s plus 1 cube dx. Then when you integrate this, you're going to get s plus 1. Integral of this is, okay, so here we are using by substitution. So I have -2, then u to the power -2. Let u be equal to 1 plus s plus 1. So that will give me negative. So that's the reason why I have negative here. Okay. So this will be u over s plus 1. Please, you can take your time and integrate this. Oh, okay, so it's even here. They are saying that we use integration by parts, by substitution. So we have, so if I have integral of 1 over u, 1 over x plus 1 to the power 2, yes, I will let u be equal to s plus 1, du be equal to dx. So I come back here, I have integral of 1 over u squared dx. And du. So this will be u to the power -2 integral du. And this is, when I integrate it, to be u to the power -2 plus 1 will be -1 over -1 over -1 and plus c. And this is minus u to the power -1 plus c, which is the same as -1 over u plus c. And we know that our u is, so I come here, I'm going to get -1 over x plus 1. So that's how come the integral of that is. Then is, anything that we have this to be, so I have minus and I already have minus here, so we have 2 over x plus 1. The same thing for the, I mean, yeah, I'm not going to go tray. So we want to integrate 1 over x plus 1 to the power 3 dx. So you let u to be x plus 1, then your du will be equal to dx, like this. Then I come back here, this will be integral of 1 over u to the power 3 du, which is the same as integral of u to the power minus 3 du. Then by the integration, this is u to the power minus 3 plus 1 over minus 3 plus 1. So this is u to the power minus 2 over minus 2, which is the same as 1 over, so negative 1 over 2u to the power 2. And my u is, so minus 1 over 2, u is s plus 1. So that's how come squared. So that's how come the other one is this, is minus 1 over 2 into bracket s plus 1 squared. So you put everything together and then you get this. Okay?
Okay, madam.
Hey, maybe integration by substitution, by partial fraction. There's another one that you have to integrate something. So there are some that when you integrate, you're going to get cos. For example, if I want to integrate, you say no big about yeah, sure, but I don't know. It used to be in the notes.
Madam Pacho Charity or sorry, Madam Charity or sorry, another young one.
Our notes anymore, our class anymore.
Or any ordinary horsey.
And I'm an take you over, my bread.
Madam
Charity.
Madam Charity.
Yes, madam.
Take over.
Let me finish with the integration on the application. I will say upon time.
3:30.
5 o'clock.
4 o'clock.
3:30.
5 o'clock.
I'm here the first. Okay, so I think I wanted to maybe I want integral. Okay, so I'm saying no to EBF. Now, baby, the cost inverse and others. Integral of cost functions. I don't know. What is the week 3? Week 2, no. Let me see. For example, if you have integral of maybe integral of 1 over square root of 1 minus a squared or something like that. You should know that because Mikaisa noting they said that it has consequences in integration. So it didn't come. For example, if you want to integrate 1 over square root of 1 minus x squared. You should know that when you integrate 1 over square root of 1 minus x squared, you will get sine inverse of x. So you should know all this. Integral of 1 over 1 plus x squared, you should know it is tan inverse. So please take note of these ones too. You can get examples on that. I don't know. We used to have some things in the notes. Okay, so we are done with integration by substitution, by parts, by partial fraction. The next one we want to look at is the integration by reduction formula. So the formula didn't come. Reduction formula. So we want to construct a formula that we can use to solve some kinds of questions or problems. So example, we want to construct reduction formula for in is equal to integral s to the power n e to the power x. This is a general function. So we have x to the power n e to the power x dx. And thus we know we can use integration by parts. So what kind of problem is this one? What type is this one? Is it a type 1, type 2, type 3?
It's type 1.
Type 1.
Type 1. So the type 1, it says that my u will be, what should be my u? My u should be x to the power n. Okay. So the type 1, I will let my u to be s to the power n. So when I differentiate, my du will be n s to the power n minus 1 dx. Then I have to, so my v will be e to the power x dx. So I have to find v. So my v will be e to the power x. And remember the formula is uv minus integral of v du. So I'll make substitution. My u is s to the power n. My v is e to the power x minus integral of my v is e to the power x. My du is n s to the power. I'm interested. And so like I said, my children, let me try it. Okay, so example, we want to integrate s to the power n e to the power x dx. And you said this is type 1. So the formula for integration by parts is integral of u dv is equal to uv minus integral of v du. So it means that the original function, we have u and dv. So you said it is type 1a. So my u will be s to the power n. Then when I differentiate, I'm going to get n s to the power n minus 1 dx. So that's my du. In the formula, I need du, so I've gotten du, but I will need v2. So, and then in this, I have dv. So my dv will be e to the power x dx. So let's find v. I will integrate, and my v will be e to the power x. So that is it. So I go back and make my substitution. Integral of u is x to the power n, dv is this dx. So in the formula, I have to get my u. My u is x to the power 5. My v is e to the power 6, e to the power x, minus integral of v, which is e to the power x, and then my dx, which is n s to the power n minus 1 dx. So this is the same as s to the, is it 5? It's n minus 5 too. S to the power n, e to the power x, minus n is a constant, so I can bring it out. N integral of s to the power n minus 1, e to the power x dx. So this is the general formula. So I've been able to construct a formula. Now I want to use formula to solve for integral s to the power 3 e to the power x dx. Okay, so I want to use this formula that I've constructed to solve this. So the formula says that I'm supposed to get x to the power n. So I will get x to the power 3 e to the power x minus n. Here my n is 3. Integral s to the power n minus 1, which is 3 minus 1. I have 2 e to the power x dx. Please, are you following?
Yes, please.
Yes, madam.
So I constructed a reduction formula and I'm applying it here. So this is s to the power 2 ex minus 3, but I can apply the same formula here. So I want to apply it here. So applying it, s to the power 2 e to the power x. So I want to repeat the same formula, which is s to the power 2 e to the power x minus, here my n is 2, so 2 integral of x n minus 1, which is 2 minus 1 x, then e to the power x dx. So
Madam,
that's
the
what I
first
get.
Madam, the first x, it was exponent 3, but you made it exponent 2. Why?
2. Okay. Sorry, it's a mistake.
Okay.
So it's 3. Okay. So this is s to the power 3 e to the power x minus. So this is 3x to the power 2 ex. Then 3 is multiplying. I have plus 6 integral of x e to the power x dx. I can apply the formula here too. Okay. So this is s to the power 3 e to the power x minus 3x squared e to the power x plus 6. Then let me apply it. So the formula is x to the power n, which is my x, and then my e to the power x, which is e to the power x, minus, so I have minus. My n is 1, so 1 integral of, then I have x to the power n minus 1, which is 1 minus 1 is x to the power 0. Then I have e to the power x dx. So this is the same as s to the power 3 e to the power x minus 3x squared e to the power x plus 6x e to the power x minus 6. Integral of e to the power 0 is 1, so I have e to the power x dx. This is the same as e to the power 3 e to the power x minus 3x to the power 2 e to the power x plus 6x e to the power x minus 6. I can integrate this, right? So please let's integrate it. When I integrate this, I'm going to get e to the power x, then plus c. Aye, dear. Ekoye.
Madam Yansan Faso, Madam Yansan Faso.
Hello, madam.
Okay.
Hello, madam.
Yes, sir.
The
Yes, sir.
integration, can't we separate them and then afterward we bring everything together?
In the what? Please, I'm not getting it.
I said the various integration. Can't you do them separately afterward? Put all of
Oh,
them
you
together?
can do that. You can do that, sir, please. You can do that.
Straight away.
And then after that, you put the bomb I bow when you so. Okay, so let me clean it, then we'll do it one after the other. Oh, I've cleaned the general one.
Doc, please, when you are done, kindly share your write-up with us.
I should share my
Write-up, the one that you are writing on the screen. You share it with us. Thank you.
I hear. But I've been cleaning them all. Some of them I cleaned them. Okay, so so the final one is x to the power n e to the power x, then n this. So this is the reduction formula. And the question is, we want to apply this formula to integrate. It integrates x to the power 3 e to the power x dx. So the first one will be x to the power 3 e to the power x minus 3 integral of x to the power 3 minus 1, which is 2, e to the power x dx. And we know that we can apply it here. So our brother is saying we should do it again. So we want to integrate x to the power 2 e to the power x dx. Then we'll come and substitute. This will be x to the power 2 e to the power x minus 2. Then integral of x to the power 2 minus 1, which is 1, e to the power x dx. And then we can apply it here too. So we'll come here, then we'll have integral of x e to the power x dx, which will be x e to the power x minus, here our n is 1, integral of x to the power 1 minus 1 is 0, is x to the power 0, which is 1. So I have e to the power x dx. So this is the same as x e to the power x minus integral of this is e to the power s plus c. So I'll start substituting this into this. So this will give me x to the power 2 e to the power x minus 2 into x e to the power x minus e to the power s plus c. So I will expand this. This will give me x to the power 2 e to the power x minus 2 x e to the power x minus, plus 2es plus c, 2c, which is c. Then I'll substitute this into this. So this will be x to the power 3 e to the power x minus 3. So I have minus 3. This is x to the power 2 e to the power x minus 2x e to the power x plus 2 e to the power x plus 2c. So when I expand, I'm going to get x to the power 3 e to the power x minus 3x squared ex plus 6x ex minus 6 e to the power x, then plus 6c, which I can call it c or something. I can make this one k. Is it okay?
I think this one is okay.
Is it okay? This one is okay. Okay, so let's continue. Let's see. So we have another one. So this one, they did not apply it, but we decided to apply it. So we have this and this, and they are saying that let this one be. So we'll call this one ni subscript n minus 1. So when I integrate I sub n, which is this formula, it's going to be s to the power n e to the power x minus n I sub n minus 1. That is it. Then I want to apply the reduction formula for this. I want to construct reduction formula for integral sine to the power nx dx. So I want to use the integration by parts. Abrimpo. Okay, so let's look at that one. Wait there, please pay attention because we Dawson. So please be aware want to construct reduction formula for integral sine to the power nx dx. So this can be written as sine to the power n minus 1x sine x dx. It's not, no, I don't do it. Authorize this. Please excuse me. Okay, so I have sine to the power n minus 1x sine x. So I want to use integration by parts. So I will let my u to be sine n minus 1x and my dv to be sine x. So please there should be x here, dx. So when I differentiate this, what do I get when I differentiate u with respect to x?
You take n minus 1 sine
n minus 1 times
exponent n minus 2. Where you subtract another one. So
sine n minus 2 dx, right? Then let's integrate the v. So what will I get for v? Integral of sine s ds will give me minus cos s. So let's go to the formula. The formula is integral of u dv is equal to u times v minus integral of v du. So my u is sine n minus 1x. Then my v is minus cos s. Then minus integral of my v is minus cos s. And then my du is n minus 1 sine n minus 1x dx. So this is the same as minus, let me just write the cos first, cos sine n minus 1x. Then I have minus minus, so this will be plus. This is a constant, so I can bring it out into brackets n minus 1 integral of cos s, then sine n minus 1s dx. So I can have something like that. So let's see if we are on the right path. Okay, something is missing somewhere. Oh, we didn't finish with the differentiation. When we differentiate u, we didn't finish. Can you see that we didn't finish? When we differentiate this, we are supposed to get n minus 1 sine n minus 2, then the differential of sine. Is it true? Are you with me?
Yes, madam. Yes, madam.
Yes, madam.
We didn't finish with that one, so I have to add differential of sine is cos s ds. So my ds is not done. I have to add cos s ds. This is cos s then dx. So the function now becomes minus cos s sine n minus 1x plus n minus 1 integral of, so I have cos s, so which is cos squared x, then sine, oh, this is n minus 2, not n minus 1. This is n minus 2. So minus 2 minus 2. So n minus 2x dx. I want to repeat the first one, which is minus cos s sine n minus 1x plus n minus 1 integral of. But remember that cos square is the same as 1 minus sine squared. Is it true? X. Hello.
Madam.
Hello.
Yes, madam. It's true.
Am I online? So this is minus cos s sine n minus 1x plus n minus 1. Then I want to expand this. So when I expand this will be sine, or by indices, sine n, sine nx. So please, this is multiplying this. So sine n minus 1 will multiply 1, and then sine squared s will multiply this, and by indices will be sine nx all dx. Is there a hand up? Okay, so there's no hand up. Let's continue. Oh, yeah, Hannah, we are here. Please, are you okay after this point? Students, you're on tank assignment. Dorcas. Is it okay?
Yes, madam.
So I'm expanding this. So n minus 1 will multiply the sine n minus 2x dx. I'm expanding. Then n minus 1 will multiply this negative sine nx dx. So I have minus n minus 1 sine. So the integral didn't come. Sine nx dx. Remember, the original question is sine nx dx. So the right-hand side, we know, is integral of sine nx dx. So this is equal to negative cos x sine n minus 1x plus n minus 1 integral of sine n minus 2, please, is 2, n minus 2 x dx minus n minus 1 integral of sine nx dx. So you see that you have sine n minus sine nx dx on the left, and then you can have sine nx dx on the right. So I'll group the two like that. Group negative comes to this side, it will be positive. So I have integral sine nx dx plus n minus 1 integral sine nx dx on the left is equal to negative cos x sine n minus 1x plus n minus 1 integral sine n minus 2x dx. The left hand side, when I open this one, n minus 1 multiplying sine nx dx. So I'm going to get integral sine nx dx plus n integral sine nx dx minus, so the negative one is minus 1 integral sine nx dx is equal to minus cos x sine n minus 1x plus n minus 1 integral sine n minus 2x dx. So on the left, you can see that you have integral sine s dx, and you have negative, positive and negative. So this can go with this. Then I'll have n integral of sine nx dx is equal to minus cos s sine n minus 1x plus n minus 1 integral of sine n minus 2x dx. But I want to find integral of sine n, sine to the power nx dx. So I will divide through by n. So I have integral of sine to the power nx dx is equal to negative cos x sine to the power n minus 1x divided by n plus n minus 1 over n integral sine n minus 2x dx. And this is the reduction formula for integral sine to the power nx dx. Yeah, so we have the reduction formula, and we can use this to solve. So I want to use this to solve sine to the power 3. So my n should be greater than 2. And yes, because you were not paying attention or you were not following, because of n minus 2 here, my n should be greater than 2. So I can choose n equal to 3. So I want to use that to solve integral sine to the power 3x dx. I want to use that, the integration formula we just constructed to solve this. Remember the integrating factor. Okay, let me write. It is s to the power n is equal to negative cos s sine n minus 1x divided by n plus n minus 1 over n integral of sine n minus 2x dx. So that's what we just constructed. And we want to integrate sine to the power 3x dx. So this will be negative cos. I'm applying this. So negative cos s sine 3 minus 1 is 2x over 3 plus 3 minus 1 over 3 integral of sine 3 minus 1 is 1x dx. So this is minus cos x sine 2x over 3 plus 2, this is 2 over 3. Then integral of cos x, is integral of sin x is negative cos x, then plus c. So this is minus cos s sine squared s over 3 minus 2 over 3 cos s plus c. So we've been able to apply that integration reduction formula. You can have your n to be 5, 7, 4, any value, and you should be able to apply it to solve.
The application is not difficult, but the proving.
So it's minus sine n minus 1 s cos s over n plus n minus 1 over n integral of sine to the power n minus 1 x ds, and I said my n should be greater than 0. So for this one, when n equals to 5, ours we chose n equal to 4. But when n equals to 5, you're going to get negative sine 5 minus 1 is 4, x cos x, plus n minus 1, which is 5 minus 1, which is 4 over 5. Then integral of sine 5 minus 2 is 3x dx. Then you maintain the first one, then plus 4 on 5. Then you have to apply it for when it is 3. When it is 3, you're going to get minus sine. So 3 minus 1 is 2x cos s over 3 plus 2 over 3 integral of sine x dx. So you expand, you can maintain the first one. The second term will be 4, and then 5 times 3 is 15 sine squared x cos x minus. So 5 times 3 is 15. Then you will have to 4 times 2 is 8. Then you will have to integrate sine s, which is minus cos s plus c. Ebusuafo.
Madam.
Ekobia.
Akra.
My aspect here, Madaya man for me, no.
And I taba pao. A bus session impu. And yet, it's Senator Ba, a bapa and titans. A bit me about.
Madam, section A.
At Abba section A, any section B, to remember baby. But Miss I didn't yet, yeah, it had about section A. To say to remember section A, then the section B, they are by sub. And yes, sub question, put sub. The question be but you have to do it.
Madam,
okay, so what
to read this? Madam, so meaning this is a proof to Sabian fans unya question bisa like a proof
you have to construct. You have to construct.
So we need to
are constructing the formula. Yeah, every time you have to construct.
Okay.
The construction you have construct one. So like I said, construct a reduction formula. So construct a reduction formula for this. So you now construct. So you apply it here.
But I mean, I say, I don't know session area. I don't quite ever solve session you.
And yet the main thing I but 1 hour won't be sir. So most of the things I repeated them, but 1 hour you will not repeat them. Say me I'm working and me and come you see board in like that. Maybe I may you see the less than 5 lines or maybe 5 lines. So if it's your exams work, won't actually be say where I was trying to explain things to you. Okay, so another one want to construct.
Madam, I have to say, your mama have been made. Careful, dear mama.
If I try the baba why yes, yeah, if I'm
Nanya,
banana,
Mama,
Maham, one match.
Mama tutorials, I don't know.
Yeah, the baba why you patcho. Yes, so the baba. So we want to construct a reduction formula for tan from 0 to pi on 4 tan to the power n s dx. Okay, so the tan n can be written as tan n minus 2x times squared x dx.
Madam.
Yes, madam. Yes,
That's why
madam.
you incorporate.
Yanko break. Na me line ne kati yen nsam mo jema ho me kakra.
Say again, yes, you ain't break it. 3:30.
And mami me aka me one slide aka we ni we pe na me wie. Na mo nko break aka na madam me beto aso with the application. Some say me nkonti. Na me jema ho me na madam be ya 1 hour no. Why? So mo jema ho me be 30 minutes and then she will use the 40 minutes to or maybe some minutes to do the rest. Why?
Yeah, Madam Ensoso.
So we want to construct integration formula for. So let I sub n be this function. So that this function is the same as, so tan n can be written as tan n minus 2x tan squared x. We are writing tan squared x because we know the identity for tan squared x. So I have integral from 0 to pi on 4 tan n minus 2x. And I know that tan squared x is sec squared minus 1. So in place of that, I'll substitute this dx. So this is integrating from 0 to pi on 4 tan. So I'm expanding this. When I expand the tan n minus 2, tan to the power n minus 2 will multiply sec, then it will multiply the negative 1. So I have it as integrating from 0 to tan on 4, pi on 4 tan n minus 2x sec squared x dx minus integral of 0 to from 0 to pi on 4 tan n minus 2x dx. If in is this, then I can represent tan n minus 2 as tan I subscript n minus 2. So in place of this, I will just write tan n minus 2. It means we are substituting. Now I want to use integration by substitution for this. So let u be equal to tan x, so that here I have u to the power n minus 2. Then I have to find my dx. So my du will be sec squared x dx, so that my dx will be du over sec squared x. When it comes here, when they come here, it's going to be integral from 0 to pi on 2. So that's why we are using integration by substitution. So you can construct the reduction formula. You can use any integration method that you use. But the two that we just solved, we saw that the best or the appropriate one for us to use now is the integration by parts. And here we are using integration by substitution. So here, this one will be u to the power n minus 2. And my du is sec squared x du. So when I make the substitution for u, the sec squared, this can cancel the sec squared. Okay, my matrix. The man can one shine. Okay, so starting, we have integral from 0 to pi on 4 tan n x dx. And I'm saying this is the same as pi on 4, 0, tan n minus 2x tan squared x dx. And I'm saying this is the same tan n minus 3. And I'm saying that tan squared is going to get integral from 0 to pi on 4. So this will multiply this. I have tan n minus 2x sec squared x dx minus integral from 0 to pi on 4 tan n minus 2x dx. Okay, so I'm saying I can write this as integral from 0 to pi on 4 tan n minus 2x sec squared s dx. And then I want to represent this, so I can see that. So in the question it says that let the whole of this be I subscript n. So when I compare this and what I have here, I can represent this as I subscript n minus 2. Okay. So I want to integrate this part. So let my u be equal to tan x, so that when I differentiate, the u will be sec squared x dx. So when I make the x the subject, my dx will be equal to du over sec squared x. So I make the substitution. I'm going to get integral from 0 to pi on 4. The one line there. I on 4 my squared x, but my dx is now du over sec squared x. So this can go with this. Then is I 2. So this I now have integral from 0 to pi on 4 u to the power n minus 2 du minus I squared 2. So I can integrate this. I know that when I integrate this, it will be u to the power n minus 2 plus 1, all divided by, so this will be u to the power n plus 1, which is n minus 1 over n minus 1, then minus I n minus 2. And I know that my u is tan. So the final answer will be tan n minus 1 over n minus 1 minus I n minus 2. So that's what I'm supposed to get. Okay, so I have 1 over n minus 1. Then, okay, so 1 over n minus 1, u to the power n minus 1. Then I'm integrating from 0 to pi on 4. So I have to include the limits. Okay, so limits of integration, that is from 0 to pi on 4. So that's what I'm doing now. So 1 over n minus 1. And then I have to substitute the upper limit, which is tan pi on 4, n minus 1 minus tan 0, n minus 1, or minus pi I n minus 2. And what is tan pi is 180. So 180 on 4 is what? 180 on 45, right? So what is tan 45? Hey, school for me, try more.
1.
Okay, so tan 45 is 1. So I'm going to get 1 to the power n minus 1. And then times 0 is what? What is times 0?
0.
0.
So 0. Okay. So I'm going to get this. So the final answer will be 1 over n minus 1. So this is 1 and then 0 minus that. So this is my final answer. So be 1 over n minus 1, and this is 1 to the power n number. So 1 over n minus 1 minus in. That's okay. So far, you have been introduced to integration by substitution, integration by parts, integration by partial fraction, and then trig integral, and then reduction formula. Reduction formula didn't come. So you have some questions here. Thank you. So this one, you want to construct reduction formula for in is equal to integral of cos to the power nx. I did it for sine to the power nx. So please try this one. Cos ns dx. And try and integrate all these. So this one, use partial fraction. I think this one will give you the tan inverse that I was talking about. Something like this. This will give you a tan inverse. So the first one, this one, you have a over x minus 1 plus b over x squared plus 1. And you have to find your a and b. And after that, you get something like this. And this should give you the tan I was talking about. So please try this. Try this, please. These questions. Okay, so I'm done with the integration formula. Thank you very much. Any question for me? I was looking for you. Where did you go? Where did you go? Any question?
I was not
Madam
available, so I left.
Madam, the question is, bro, boy, yeah, Dawson.
Yeah, sure.
Madam,
Okay, so Madam say, yeah, but breaking. Let me see. Madam Charity, are you there? Madam Charity.
Madam, we do a questions. I did Dawson.
What's the meeting doing to watch on the corner? I don't know next year. Or Sarcom.
Madam, now come to them, Mr. Jesse, baby.
Okay, Abra, yeah, that for free.
To them also, yeah, last week, then I had to the Friday, so that they will suggest
Madam,
integration application.
Okay, so please, Madam is saying that if you can meet him another time, not today, another day.
Yeah.
Yes.
We will agree with what she's saying.
Madam, yeah. I didn't break.
Madam, tutorial questions,
At Madam, I'm say you. At your media.
Okay.
So week 5 next week we'll meet week 5. But if you want it on Friday, Sammy from Code, please, are you there? Our code monitor, please, are you there? Code Monica. Okay, so please, we'll end here and continue. So please, Friday, what time, madam?
What's suggested?
Okay, so please suggest the
Yeah,
time
but
that
it's
will be for you. Okay.
Madam, Friday
So
we'll
thank
be
you very
meeting
much.
with hello. Friday, the IT we have Dr. Frank. We'll be meeting Dr. Frank as well from 5 to 7.
In the morning.
No, in the evening.
Okay, so let's discuss the time.
Maybe it can be
please
any
discuss.
other day aside the Friday.
Madam, then the Friday.
Any other day will be
from dawn
aside Monday to.
Madam, provided you will get a chance.
Okay, so please let's discuss it on the platform, on the WhatsApp platform. So madam is available. You choose your time and then she will be available to take it. Okay, so thank you very much and see you on your so maybe next semester. Those who will be reading advanced calculus and other things and OD will meet.
Madam,
so I wish
please,
you all the best. Friday,
the rest of the material.
No.
Madam, the rest of the material, the course material.
The rest of
the course material. I think we have only up to week 2.
Don't you have all?
No, please.
Okay, please, I'll share it on the platform.
Thank you.
Share it on the
please,
platform.
which of the platform?
So thank you very much.
All centers.
I don't know. We have some further calculus platform, so we share it there.
The computing student, we are not on it too. Those doing the computing, we are not on it. IT.
Okay, so we'll try and share it from anywhere. Maybe we have some switch, something. So I will share it on that one too.
All right, thank you very much.
You're welcome. Okay, thank you very much. And go and eat your fufu and bangkun and mutu and everything.
Barikadasara.
The name said Americano, so thank you. Okay, bye-bye. Bye.
Bye, madam. Bye.
Bye-bye.
Guilty, bye-bye.
Oliver, self-arrangement.
When they as the moon. Madam
Madam, sorry, cry.
Oh, say you quiet.
Gifty.
Danny?
Gifty.
Daniel?
Gifty. Hey, Gifty, or Cotran as well.
The recording is still on. The recording is still on.
Oh,
Hey,
okay,
Madam Maria.
okay.
Madam Maria.